what's going on here. So what we've got is a breadboard over here. And on this breadboard, which is powered right now by these AA batteries. Okay. And I'm following a kit right here. It's online. And this kit is called SmartyKit. And basically you buy this kit from this company called SmartyKit.io, and you're putting a computer together from scratch. And what's cool about it is that at the end you'll actually have an Apple One computer, which is really cool. All right. And they've got this interactive online assembly system, and they've given me this box, and the box has all the chips for stuff like CPU, RAM, ROM, and chips, video chips, all the kind of stuff that you would need to put a computer together. So you get to learn about computers while you're doing it. And the kit is really posh and pretty cool. It comes in this nice box. And I went and I bought a multimeter as well here, so I can go and test the voltage and stuff, which is cool. So I worked on this for a little bit while and ended up having a challenge because I couldn't get the keyboard to work. Turned out it was a bad chip, so they sent me a replacement, and now I think I've got it working. So here's what I'm going to do. I'm going to plug in this keyboard that I got. And the keyboard is an original PS2 keyboard, and these are before USB, right? So your keyboard looks like this. Okay, so you can actually test the pins on the keyboard there. And what's cool about this is I can plug that in here because they put this board together. So we're plugging the keyboard in right there. Okay, and this here is plugged into the keyboard controller. So I don't have a full PC right now, right? You can see my board is kind of empty. I've got my screen up here, which is not plugged in, my little tiny screen. I've got a bunch of buttons and stuff that are not currently hooked up because I'm still going through the process. Okay. And over here, now with my keyboard right here, let's turn it on. Cool. Okay, so now we see the clock going. Okay, and this light right here represents the clock for our little computer here. And we should be able, if I learn how to do this, to plug in my multimeter here and see that clock. I'm going to have to figure out how to learn how to do this because it's a little janky right now. Okay. Because I want to make sure you can see it, but I don't want there to be too much glare. So forgive me for a second as I learn how to do this. I am actually going to record this. So if you're on TikTok, this is actually live on my YouTube, and it'll be recorded and it'll be on my YouTube. So if you don't like the way TikTok sees it because it's going to be horizontal like this, feel free to go to my YouTube right now and then rotate horizontally, and it'll be up on YouTube. So I'm going to be goofing around for about an hour here, and then you can check all this out on my YouTube. And those of you who are on the YouTube, hello, how are you? So let's take a look at this. Now we're on a breadboard here, so we can see our voltage going here. So this is our negative and here's our positive. So I'm going to reverse my wires here. And what I'm going to do actually to make this easier is I'm going to take a pair of alligator clips. And alligator clips look like this. They look like alligators. So I'm going to put one here. And then I'm going to get a pair of black alligator clips. And I'll put it like this. I'm going to put these over off in the corner, and that's going to allow me to plug those clips in a little easier. So now I can go like this. So now I'm going to put those on our light right there. Okay. So what we're doing here, my friends, Wayne is suggesting I point the ring light at the wall. You're absolutely right. The problem is I have taken the camera here and I've stuck it in the ring light, so the ring light's actually facing straight down, which is not my finest hour, but I'm working on it. All right. So now we're going to look at our multimeter here, but I need to change the range. I'm going to zoom out a little bit here. And I'm still learning how to use this. And it's very beepy. So this is a multimeter. This is actually a little kind of a poor man's oscilloscope slash multimeter. And what I want to see is I want to see the light going on and off and on and off and on and off. I'm looking at the chats here as well. Yeah, this is a multimeter oscilloscope hybrid. These are little cheap ones that you can get. There's a couple ways I can do this. I didn't have the money for a full like thing. You know, I didn't want to go over the top and buy a real multimeter, but I got this little cheap one. And the biggest challenge with it is figuring out the range. So we're talking about a small number of volts here, 5 volts. And I want this thing to be smarter than that. So there you go. So that's now, the range is wrong. You see how it's kind of moving up and down? I want to see a nice up and down on that. So now I need to figure out how to change the time. There we go. Look at that. Look at that, kids. Okay, so now what we got going here is we see the clock right there going up and down, on and off, and then we see it represented in the chart right there, which is cool because that's showing us that we're doing the right thing. Okay, so that's cool. So now we have a clock. Make sense? All right, so I'm going to put this aside now. I'll bring it back later. And we'll switch to full screen here. So now we turn this on. I've got my keyboard now, my $10 keyboard from Goodwill. Sawtooth pattern. That's right, Aaron. Thank you. That's a sawtooth pattern. As I type on my keyboard, which is my PS2 keyboard, we're actually getting the ASCII output right here. Because what we're doing is we're listening in on the data pins of the keyboard controller. So here's our SmartyKit keyboard controller. This will be controlling the keyboard. So Wayne is saying it would be cool if it has video out. It actually does. That's funny that you point that out. It's probably going to take me a couple of hours, Wayne in the chat there. But when I'm done, I will have added video out. And this video out is part of the kit that they give you. And there's this connectors bag right here. And in that is an RCA video connector. So what I'm going to end up doing is I'm going to connect the video to this, to an RCA to HDMI to OBS output, and I'll be able to show you the actual video output of the Apple One computer when I get it done. So I will be able to pull that off, which is cool. Oh, I'm sorry. So then, as I thought I was clever there, the sim racers made the observation that the multimeter needs its own video out. You're absolutely right. I think the other challenge that I'm having right here is the little Logitech camera that I'm using right here is a little aggressive with the autofocus. So if I bring it close, you can see it, but then I have to wait a second while it refocuses. So good point. Thank you, Wayne. And thank you, the sim racers. Appreciate that. So now we have keyboard output. So that's cool. So we've proven that the keyboard works. And what we're going to do is we're going to take our stack here of breadboards and we're going to kind of build upwards. So we'll have video at the top, we'll have memory, CPU, and work our way up to the top. And the way that we're going to do that is by following their instructions. So they got this really nice instruction set over here on the left. And you can see in that instructions setup, they stack them. Display and TV, I/O controllers, I/O ports, CPU, and memory. Okay. Pete Codes just showed up. Thank you for hanging out with us. Yes, we did in fact get the new keyboard decoder chip. And you can see here I'm getting nice, look at that beautiful output. Each time I press a key, I'm getting that ASCII output right here. So the keyboard decoder chip did work. Thanks to our friends at Smarty Chips for sending me that correct chip. So now here's what I got to do. I have a test bed here where I'm testing my keyboard output. Now I've got to figure out how to get back up to date, because if we look on the left-hand side, as we go through this process, we recall that I set up all of my power on the outside here. So here's my 5 volts, and we've got it going all the way down. So we have power everywhere on our breadboards. Now I'm going to have to unhook this keyboard connector and do things. There we go. So we did power. Now we got to catch up to where we were before. And we're going to pull probably all of this out here. And in the process, probably it'll be a little messy for a minute. Be messy for a little bit. Yeah. Wayne is asking if we have any BBC Micros. BBC Micros were not that popular out there. That was more of an English thing, but we do have people who are familiar with those. So we've got that working, which is cool. All right. Now, the question is, all this video work over here that I'm watching happening, I'm going to turn this off. I'm happy that it works, but I am going to pull this whole thing out. So this is our keyboard controller, and we're going to pull that aside. So our keyboard now is going to go off to the side, and it's going to be video controller time. All right. So we're going to have to fix this and figure out a way to get back to where we were before. Back to where we were before. And if we can do that, I think it'd be nice to get to the point where I at least have a little bit of video output. So I'm looking around here, make sure I have all my parts. So our keyboard controller is going to come out of here. We're going to come back to that because I want to do this the way that they intended. So there's our keyboard controller. We'll put him off to the side. Okay, so now we are broken. This officially doesn't work anymore. But we're following this instruction on the left-hand side. And I'm taking a look here, and I'm going to install that video controller module. And I think I can reuse a lot of these things. Sadly, I'm going to pull all of these fellas out of here, I think, probably. But I don't know, maybe we'll stick there for a minute. This is a thing that I have trouble with when I'm working with breadboards, is I get all in my head about doing this, and I don't want to ruin a good thing. Like I got a nice setup here, and then I end up feeling bad that I'm going to mess it up. But you can always do these things over again, I suppose. So take my video controller here, and I just need to make sure I got things lined up. And I'm looking at the way that they've got this done here. And you have to kind of look closely at these. It's a little bit challenging. Let's go picture in picture here, because I'm counting the connectors and I'm looking at where they were. So this video controller kind of gets dropped in where I don't want to be off by one. And isn't that the challenge? 30 is there. So I think that's correct. I can count it. I can see that that's voltage. Okay. So Wayne points out, don't they say the location in the docs? Let's make sure, because the docs sometimes change. And they've been updating these docs. What they have here, if we switch it like this and switch over to the side, they have this documentation, but I'm trying to do it in split screen. And it's a little bit hard to see, you see? That's like pin 10, and that's kind of hard to tell. So I'm trying to figure out the best way to do this. This looks a little bit blurrier than I did last time. I might need to switch to 4K and then zoom in. So we did all the power. Ah, there it is. You're right. There is some stuff there in the corner where it tells you enough information there. So that's board 4A7. I see what you're saying. Video controller, board 4I8. All right. So I think that's saying that's I8. So the upper left corner is I8. So I'm going to bring that up a notch and double check that. So that was a good reminder. Thank you, Wayne. I 9, 8, 9, 10. Okay, I think that's correct. It's a little hard because mine looks a little different than theirs. Not too far over, but as soon as I get the video back, I'll feel comfortable. So here's my power and then ground. I'm looking right here. And then there's this guy here. Okay, I'm going to pull that fella out of there. So now they have me putting the video up at the top. So that was this fella here. And they're saying I21. So here's our I row, and we'll go over to 21. Okay. But I want to tell what pin they've got me on here, and this is where I think things are a little challenging, is that I'd like this to be clearer. So I'm going to zoom in. See? There you go. That's a little easier. So what I'm kind of interested, this is really challenging here. You've got 21, 2, 3, 4, 5. So A0 is on 25, it looks like to me. There you go. So that's on 25. Counting backwards, 44, 3, 2, 1, 40, 39. That's on 39. So I feel like that looks correct, I think. Let's take a look. There we go. Sharov asks, what's an Apple I? Great question. Apple I is the original machine that Steve Wozniak made in 1976. It came before the Apple II, and it was built from a 6502 and parts. And we're trying to do a similar thing. Now, it's not exact. What we're doing is we're building this from a kit. And some of these kit have Arduino parts and stuff, but it's teaching us how to code, and it's teaching us about parts and computers. So we have a memory decoder and a CPU and the memory, learning about ANDs and stuff. So it's kind of like building your own car from a kit. And the fun part about this, if you think about it, is why would I build my own car from a kit? I've already got a car. Because nerds. Because you do it because you want to see if it can be done. There's absolutely no reason to be doing this other than it's fucking awesome. So we're doing this because it's stupid and we love it, and we're learning about computers. So why not, right? Isn't that fun? No reason at all. Just fun. So let's look at this. a power that's going to power the, I'm going to put this in, trying to figure out how to do this. There we go. This is a little hard to see, so I'm doing my best here, friends. We're going to put power from here to here. So I've got my wires that are pre-done. Wayne points out a gentleman named Wayne Eater. Wayne Eater has a great YouTube channel. You should check him out. And I did his PC, his 6502 PC from scratch a number of years ago, and I actually had him on the podcast. Lovely, lovely gentleman. So what we're going to do is we're going to connect our voltage from here to here, and this is going to power the screen. Now I can decide if I want to use different wires or not. This kit actually comes with pre-cut wires. SmartyKit.io is where I got this. SmartyKit.io. One of the nice things is that the gentleman who sells you the kit, he gives you everything you need. Look at that. All the small, large, medium wires, all pre-cut, pre-set up for me. So there's really just, it's a step-by-step process. So I'm just following the steps on the instructions. So here we've got voltage into there. So that's great. And then we'll do our negative. So I've got some of these wires already over here. And we're just going to hook up our ground. And a reminder that your ground, your power, let's go ahead and look right here. Let's try to zoom in. Like, let me see, how about that? So here's our power, our positive, and then our ground. You can see that it runs this way. And then I'm pulling it up, I'm bringing it up here. So on a breadboard, it's kind of confusing. Breadboards take a minute for people to visualize. Your ground and your rail, these are called rails, they run this way. So you've got power running like this. And then you get to decide what you hook up vertically here. So these go like this. So what we're doing here, friends, is we've actually got a bunch of AA batteries right here. You can see I just plugged them in there. And once they're here, that's where the power is. I have to decide to bring it down. I have to decide to distribute the power. We're building a Apple One from our friends at Smarty Kit from original parts, from parts. Okay, so we're going to look at compare our screen here, and we've got our instructions that we're following. So we've just finished the display module between the minus, and we're doing this part right here. So this is this. Okay. And then let's take a look here. We're going to hook up. I'm going to have to zoom in again because I think that's hard to see. So we're going to hook up A0 to ground. And I happen to have a black wire right here. Hook that up to ground. Now, you can see that mine aren't really nice. They're not straight, perfect lines. In a perfect world, if I cared, I would probably get a wire stripper and I'd make them perfectly like the right wire. And I probably will do that at some point. I'll make them perfect wires, but that's a little over the top right now. And what I'll do is I'll get it working first, and then I'll go back and I'll make these cool wires that are just exactly the way I want them. And then they'll probably end up looking like this, right? So like actually, I might be able to cheat and just give you an example of what that would look like. So right here, this goofy looking guy right there, I could probably do this. You know, and that looks pretty badass. That's a short black. So then I got to go and find a short white or a short red, and I'm looking all over now my kit. See if I got this anywhere. They're around here somewhere. Medium, connectors, green. Where'd my reds go? Oh, there. Oh, that's medium red. I don't know. Somewhere around here I've got red ones, but you get the idea. And then you could make it look like that. But it's not gonna hurt me if I don't do that right now. I think it's not a huge deal. Okay. Let's go to the next step. Video controller. Okay, so now we're starting to actually hook up data. Now they've got me using, and the colors don't matter, but I like to kind of keep them this way just to keep myself sane. So we're going to have the output of the video controller go up into this fella. So we've given him power, but now we need to give him a little bit more. And we're going to give him signal. And we're going to go off of A1, and we're going to go to the receiving end over here. So A1 to A0. So then we have a little signal going there. Okay. So I see 4 of those all doing the same thing. So we're building what's called a bus here. So that bus looks like this. So we got 1, 2, 3 more of these green wires. I'll try to use ones that are a reasonable length so it doesn't look stupid. I'm going to go A1, 2, 3, 4 up at the top there. And I'm going to try to get this video working before I go get a haircut because I have an appointment at 4 o'clock. Okay, so there's A1, 2, 3, 4. So these green wires here are these here. Now, I haven't done this in a month, so here's where it's going to get interesting. The next step introduces a resistor. Now, this was a mess. This pile of stuff that I got here is a bit of a mess. I've got a bunch of stuff here because it's been a month, right? So I've got all these resistors, and one of them is a pull-up resistor, okay? And you can look at these colors. And you can figure this out by looking at this color, and you can see it goes gold, red, red, red. And if you're into this stuff, you can usually look at them and know immediately that that's a resistor. But not only am I a little paranoid because I don't want to blow the thing up, but I'm also trying to learn. So I'm going to take my multimeter and I'm going to double check. You just never know, right? You just never know. Plus I get to learn more. So if I can remember how to do this thing, because it always turns off when it gets sleepy, we should be able to check this. So that was voltage. Now we have resistance. Now I remember that I put alligator clips on this to make it easier. So I should be able to just alligator clip this guy here. Okay, and that doesn't look like that's right. That's saying a number that's surprisingly large for me. I expected that to be 22. So I may have picked the wrong one, which is probably good, which is why we double check these things. Okay. Now, unless you think in the audience there that I'm doing it wrong, holler at me. Otherwise, I'm going to go and figure out if I got the wrong thing. So I'm looking around, because again, it's been a month since I did this. See, that number's changing. This is weird. Because that makes me wonder now if I've added resistance with these alligator clips. Now I'm going to remove the alligator clips. I'll try testing it manually. What am I doing wrong, kids? Now, see that? Look, that looks about right. So it is correct. That is correct. So Patrick, there we go, said, yeah, resistance should not fluctuate. It should be pretty stable. So that is correct. That is a 2.2, which is what we want. So good job. See, measure twice. You got to get it right. So that's, and we learn when we do it, right? Appreciate that. Resistance is futile. So now let's return to what we were looking at here. We can see that that's going to go there. And that's going to bring some resistance here. Now it's going to go between power and A5. Now these are long, so I can cut that and make it shorter later. Again, doesn't have to be pretty now. It's just gonna work. And then we'll worry about making it prettier later. But I want to point out again that that is running all the way up here. See? So even though it feels like it's not connected to anything, it is, because it's connected from power, and then it's running it up to A5. All right? Cool. Looking good so far. Let's go back over here and see what our instructions say. Oh, for crying out loud. So there's another one, and then a green wire. Well, let me do the green wire while I'm here. That green wire is connecting from A4 over here. That's going to leap over the top of him. And then I need to find another 2.2 resistor there. So let's find that guy. So we're looking for a 2.2 K resistor, because what we're doing, we're trying to get it to look like this. So I need this fella again, which I'm sure I have, because again, I did all this stuff a couple months ago, but I got to get back on board. I've got a bunch of these lying around, but I can't. Yeah, that doesn't look like the right kind. This one looks like it could be something. So let's test that fella. Yeah, not just a pull-up. So we're going to expect to see 2.2 here. Two 2.2. There you go. 2.2. Cool. So this is the same kind. And again, you don't have to test these, but it's a good idea to test them. Never hurts. Never hurts to double check, truly. Okay, so now I'm going to put that in here. Sorry, I'm still learning how to do all my switchers. There we go. So that's going to go here. But that's interesting because that's not even connected. What is going on here? What is he connected to? He ain't doing nothing. Is that an error in the instructions? Or is that going to be used later? I bet you it's going to be used later, because right now it ain't doing nothing because it's not hooked up to anybody. Okay. Need to jump the gap. It is not connected. So Michael is saying that. Nick says, I'm doing fine. Thank you. So supportive, my people. What a lovely group of nerds you are. Thank you for that. Okay. So it says it's milestone connected. So I'm guessing, God willing, that I can turn this on and something will happen. Now, I did leave a couple of things plugged in down here, including all of these. I'm breaking a few rules down here, but let's turn it on and see what happens. Oops. Oh, I got it. Hang on. Let me take off the... Look at that. It worked. It did work. All right. So we did output. We did get our video output. That did work. I'll turn it off. Turn it on again. Try to lever this up a little bit. Sorry about this. Let me move this. I'm going to actually try something. I'm going to move this out of the way. Yay. It worked. All right. Good deal. I see Martin Woodward just came in from GitHub. Hello, Martin. We're making a Apple I computer from original parts, or not original, but close to original parts. And we just got the screen to turn on. Isn't that fun? Sorry about the ring light. It seemed like a good idea at the time. I think the ring light's... Actually, let me try turning it off. Sitting here working with computers, and I didn't realize I could turn off my ring light. Good stuff. I haven't done this stuff since college, which is good stuff. All right, so we'll turn that off and on again just to prove it. So we've got our video controller working, sending our signal from here. We're going to eventually have video out. So when I get video out, I'll be able to send that out to the PC and show you all up on the big screen. Now, this is just the startup process of the video area, right? I want to point out that all we have succeeded in doing right now is the basics, right? We have just got the Hello World equivalent with this Smarty Kit from smartykit.io. Notice that our breadboard is still empty. It's still empty because we still have the CPU, the keyboard, the memory, and the whole process to go and do all of this stuff. And if we go and return to our instructions, the next step would be to connect the keyboard controller. Now, this was the part that I got stuck on last time, if you'll recall. Now, we proved at the beginning of this, and if you want to go to YouTube, you can back up and you can see that we got stuck at this point before because we had a bad chip. We have had that chip since replaced, so it is no longer a bad chip. And now I've only got about 20 minutes before my haircut. Let's see if we can get the terminal working. If we get the terminal working, I should be able to type and see it on the big screen here, or on the little screen, actually. Okay, so now they want a 10K resistor. Pretty sure I have one of those that I was with earlier. Good tip from Christopher there to check resistance by just looking beyond. So there's a 10K. Close enough. Interesting. So Nick just made a very interesting observation. I missed their instructions. When you click, the thing pops over the top, and Nick is making a really interesting observation here, and I appreciate that. I would not have caught that. We're missing a wire here. So I don't know. I'm going to turn that off just in case we have an issue. they basically jump to the next step, and then if you don't see it, you miss that wire. Good catch, friends. So we got to leap over this fella here. I was wondering why that wasn't hooked up. I'm surprised it worked. It'll probably be needed later, and I would have had to debug that. Good catch, friends. Very good catch. All right, so we have on A33 our 10K. Be down here. And here's one of the funny things, though. You put these fellas down, and if you're not careful, you're gonna forget which one it was. Again, you can always look at the colors on the resistors, the bands, and a lot of people, when you do this long enough, you can just look and say, that's a 10K, that's a 2. But I'm paranoid, so I'm always double checking. I'm always double checking because I don't want to make a mess. Yeah, the video popping up was annoying. So we are on A33, and we're going from voltage to 33. 35, 34, 33. Right there. What do you say undocumented, Patrick? I see the pin label is there. Okay, keyboard controller crystal. You see we've got the oscillator crystal here, and we've got another one there. And these are a little goofy and twisty. They look like this. So these are actually, you have to bend them a little bit to make them fit. And this is going to go kind of at an angle because I'm going to hit 34 and 35 at the same time, and then I'm going to give it a little twist because the keyboard controller is going to sit alongside here. Yep, Joe makes a great point. Every time one of those videos pop up, I'm going to have to watch out for that. Then we've got our little crystal capacitor listening on this leg. You can see there's the way we did it before. So these fellas are going to show up. And I want to point out again, it might look like this, but I can also cut it to make it look like that. We'll see if the haircut reminder pops up and I don't get in trouble. I don't want my barber on my bad side. So this fella is ground to 34. So that's good right there. And then we're going to put 2 of them, just like over there. So our keyboard controller module, and that's going to be the one that we just used, that was the one that got fixed. This is where we got caught last time, for those of you who may have been hanging out with us a month ago. Question here in the chat from Nick. Does the resistor matter if it's one way or the other? This is a great question. With resistors, it does not matter left to right, but with diodes, like a light emitting diode, one leg is longer, and it does matter. So with capacitors and stuff, it doesn't. With a diode, like, see how this leg is longer? That is your positive, I believe. And folks in the chat can correct me if I'm wrong. Here's another kind of example. You see how they make the leg a little longer. So that does matter, but with a resistor, it does not. Okay, good questions. Good questions, friend. All right, so we got that fella. Now, keyboard module, this is where we got nailed last time. And we're going to double check our oscillator pin to make sure that they line up nicely. So now we've got our video and our keyboard. Now I don't have the sticker because our old one is broken. Where is that sticker? Where'd my bad keyboard controller go? I wanted to make sure I didn't use it again, so I buried it somewhere. But it's a little sticker that says keyboard. I'm looking around for that. Because when the kit comes and they give you all of these cool layouts, and then they give you stickers. So now I'm thinking I'm not going to have the one marked keyboard, which is a damn shame. I'll have to go and find that a little later, but that's my keyboard right there. That's my keyboard module. Okay. Now we need to figure out how to plug our keyboard in, and we're going to need power for the keyboard. So we're going to take our voltage from this rail up into voltage. Now you can't really see. Let me see if I can zoom in on that, because we're at a lower resolution here. You see this VCC, our voltage and our ground? I can see that really small here as well. So we're going to bring up some voltage here. And we can bring that from this rail. I happen to have a little tiny wire there. I'm going to run out of these little wires in a second. And then you can see that they are bringing in the ground right there. Ground, ground. And if we achieve this, then we will have gotten farther than we did last time, which is great. Okay. And then you get that sense of achievement. Okay, so now we're bringing in voltage here and here. I'll bring it in from 40. Got to make sure that we don't pull it from the wrong rail. You don't want to accidentally plug one into the other, which is definitely a problem. Okay. And then our next move here, a 220 ohm resistor. Now this is going to hook up the clock, I betcha, because we're going to have a clock running here. This is a low rate clock, and we're going to need a 220 ohm resistor. So we're going to be off again, figuring out resistor ohms. You can see that it's got a band there. It's sitting on up at the top. It's probably that guy. But again, never hurts to check. Never hurts to check. So let's turn to our trusty cheap Amazon millimeter thing that we got here. Let's check it out. $220. Cool. So it is good. All right. So what we're doing here, if you just showed up, we are building an Apple I from scratch with a kit from smartykit.io. I'm Scott. And what we're doing is we're looking at their instructions on their website here, and we are on step 53, currently plugging in. We just did power, and we're doing a terminal right now. So if we succeed in the next 12 minutes, because I have a haircut I have to go to, then we will be able to type and have it show up on the screen, because we will have a keyboard controller and we will have a video controller. All right, so let's zoom in a little bit here. Okay, we're on ground on 54. Ground on 54. Now, wait a second. Is that 54? Oh, what is this? This is from me from earlier. This is going to come up again. Remember I had the clock running? I'm going to pull those fellas out because I suspect I'm going to end up building it from scratch again. 53, 54, and we're going to go here. This resistor is going to be to keep the LED here sane, is my belief. Let's get our focus back. There we go. Yep, exactly as I predicted. Okay, so let's bring those fellas back. So that is getting powered off of A5 here. So we'll see the clock, because the keyboard needs a clock. And then you see that leg, that longer leg is the positive. So we're going to expect this guy here. We're going to expect that to blink, because that's going to be our clock. And that clock very likely is going to feed the keyboard connector, which is around here somewhere. Ah, I still connected to the keyboard. It's down here on the ground. Okay, so we have our keyboard dealy here. I went to Goodwill and I bought a keyboard because I needed a PS2 keyboard connector. All right. Oh my goodness, look at that. Let's see if we can do this at some kind of speed, my friends. We're making a bus that's connecting the keyboard and the video controller. So I'm going to have to figure out how to zoom in here and make this easier for you all to see. So we're going from D3 to D5. I remember this. So I'm going to take all of these guys and push them down because I want to make sure that I keep them out of the way. Okay. Yeah, Pablo in the chat comments that you can use a PS2 to USB adapter, but then you have to feed the 5 volts to the USB adapter because a USB keyboard expects 5 volts. If I don't have a solid 5, I'm going to end up with a problem. So I just went to Goodwill, which is a local thrift shop, and I found a keyboard immediately. It was not hard. Okay, D3 to D5, where D is data, right? Presumably. And then D5 to D3. Okay. And then we're going to have this little bus here. Let's take a look at what that looks like. 1, 2, 3, 4, 5, 6, 7, 8. So 8 of them going from 6 through 13. And they appear to be going in that order. So we got 8 blue wires going 6 to 13. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we got 8 blue wires. And we're going from D6 to D6 and D13 to D13. And they can presumably be all the same length. Okay. And I'm keeping these lights here because if I'm lucky, I'm breaking a little bit of a rule here, but these lights should light up then when we type, which would be kind of cooler than seeing nothing. So D7 to D7. Eight to 8. When you do something like this, when you make a computer from parts, you kind of both have a feeling of, wow, that's amazing. I can't believe I did that. But then you think about Wozniak in his garage doing this. Or anyone. How insane that is, that it works at all. Because you're pushing electrons around at speed over wire, and you could see how hard it is to get these things to work. There's a joke amongst computer people that, you know, computers are just rocks that we put lightning in and trick them into thinking. It does feel like that. You really are tricking these things into thinking. And then when people are out there talking about ChatGPT and all this, why I like to do this older stuff is to think about the shoulders of giants that we are standing on. Somebody has to understand how to do this, or the system breaks down. So there's value in, I like to say, driving stick shift. But here we are putting lightning in a rock and teaching it how to think. Okay, 13 to 13. Okay, so I've got all my stuff. Did Wozniak have ICs? He didn't have full integrated chips. I think he did it with 7400 series parts, but I would have to go and read the books again to find out. But I think we can agree he was smarter than us. All right, next step, PS2 connector, right here. Now I see the PS2 is sitting on right there, butted up right there against, and I've got voltage and ground. And then you see this data and clock right there? See that data and clock? They're going to have us hook that up. There's that pop-up again. Okay, let's zoom in and see what we're doing. I think we're at the end here, and I think I'm going to make my haircut with 4 minutes to spare. So data is on 60 to D2, and clock is on D4. So data to D2, and clock to D4. Clock to D4. All right. God save the Queen. Yanni is here from Finland, I think. Hello. He says, I hope it works this time. Yeah, you're not the only one, brother. I hope it works too. I was pretty frustrated last time. All right. Let's see if it works. Okay, so let me get my keyboard. Plug in my keyboard over here. Clock is on. I'm going to turn off the light. Ha 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 ha. Hee 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 hee. Hee 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 hee. I think the thing that doesn't work is the autofocus on this camera. All right, kids. It worked. What I got to figure out is how to get output. So what I'm going to do is I'm going to figure out the video connector and figure out how I can output that screen to OBS so we'll be able to see it. So that's pretty cool. So, freaking awesome, kids. What we did, come on, autofocus, is we have our clock, we have our power here, we have our lights showing the characters in ASCII, our little 8-bit light thing down here. We have our keyboard controller feeding our video controller. No PC yet, though. We went straight into the video controller here. So I'm going to pause and go get a haircut. But I think that's pretty awesome, friends. How cool is that? So if you just showed up, if you just saw this, this is all on YouTube. If you're on TikTok and I'm horizontal, you don't like, you want to see vertical, go over to YouTube, back up. We got it working. And I want to point out again, we do now have an ASCII bit display down here, which is hot. So cool. This is nice. I like it a lot. That means that we are on step 70. And next time we will go and plug in this computer's brain. We'll plug in the CPU. Right? And then we're going to use next time this is actually not VGA. This is going to output what's called RCA. I'm going to get an RCA to HDMI adapter because I'm going to get the output of this in this format. So I got to figure out how to get that outputted to the screen so y'all can see that. But that is a pretty freaking awesome success story, kids. Thank you, everybody, for hanging out. That was fun. That was now we're in step 2 of 6 rather, of building this whole thing, which is lovely. And I know my camera work is ass, but I had a blast, and that was super fun. I'll try to get better next time. I don't know why I'm having such a challenge with this thing. Cool. Yay. All right, folks, if you just showed up, we're building an Apple I computer from scratch. I got my keyboard from Goodwill, and I got my kit from Smarty Kits. Next time we will do memory, CPU, and actually boot up the original ROM from an Apple I computer from 1976. Thanks, everybody. Bye-bye.